We'll just start with number 1 and see how many we can get done, okay? So the first one, let's have a look. The maximum range of a mobile phone tower is 34 kilometers. You pick up a signal on your phone, and so you assume you're just about in range. You travel 42 kilometers in a straight line, and then the signal is lost. So you assume you're just out of range. What was the nearest you got to the mobile phone tower? And there's a little picture there to help you. So if you look here in the picture, what's happening is, in the center of this circle is the mobile phone tower. And it has a range of 35 kilometers. And then you start here, you walk across 42 kilometers, and then you're outside of range. Isn't that it? Yeah, so you want to know what's the closest you got to the phone tower. So that would be this perpendicular distance here. You can draw a line here and a line here. These are also 35 because they're also the radius of the circle. If this is 42, that gets split into half as 21 and 21. Now, some of you aren't happy seeing that because maybe it's not clear to you that this does split it in half, which is fine. If you don't believe that this gets split in half, you don't need to assume that. What you can do, I think you still agree that this is still 42. You actually have 3 sides of a triangle. So you could use the cosine rule to get the missing angles. So, for example, if you wanted this angle, you could say 35 equals 35 squared equals 35 squared plus 42 squared minus twice 35, 42 cos the angle. So you could say then they cancel. So you get 2 times 35 times 42 cos theta equals 42 squared. So that can cancel with that. So you get cos theta equals 42 over 70. So you can get theta. Cos theta equals 21 over 35. So you know what the theta is. So now that you know what the theta is, you can get this distance by using sine, because you could say sine theta is opposite over hypotenuse. So then that means D is 35 sine theta. So when you get the theta from this and put it in, what do you get here? 25, is it? I'm not sure. Let's get the theta and work it out. So my point is, even if you didn't know that it was broken into 2 halves, you didn't need to know that. What is it? The answer here, the angle. Yeah, and then what's 35 sine of that angle? $28 exact, is it? Okay. I think that's the answer in the book, isn't it? Yep, 28 kilometers.
If we did assume that the perpendicular is half.
It's much shorter then, isn't it?
Yeah.
Yep, I only did it this way because, to be honest and to be fair, it's not really 100% clear that that perpendicular does split it into half. Yeah, but that's the thing. You have to be familiar with the circle geometry proofs, which make, I'm not particularly familiar with all the geometry proofs. So if you're not comfortable assuming that, you don't need to assume it. You can still get the answer. It's not necessary. Okay, so write this down. We'll have a look at number 2 now. I think most of you did it a different way. I suggested a different way in class, which is fine. But I think it's good to write this way down, because in the exam it's more common that they'll give you a question that needs the sine and the cosine rule. Okay, do we have that? Yeah. Sandra? Yep, okay. Number 2 was quite hard. Most people thought they got the right answer and then realised it was the wrong answer. The Earth revolves around the Sun, obviously. It is known that the radius is about 150, is that a trillion? No, that's billion. Billion meters. On January 1st, a student observed something strange, and they make their observation at an angle of 70, as shown in the picture, to the Earth. The line between A and B, that is. A is January and B is 6 months later. The A is 70, and then 6 months later, looking at the same thing, that makes an angle of 80. How far away is the object? Okay, so let's just try and draw this. So there's the Sun, and then here's the Earth on January, and here it is in July. And you've got, 70 and 80. So like an angle here, and you're looking at something here. And this angle here, you know, is 70. And this is a bigger angle, so it's 80. Now, because this angle is bigger, it means that this point is a little bit to the right in your picture. A lot of students drew the picture like this. So they made the mistake in thinking that this point is directly above the Sun, which it's not. And that's actually important later. Okay, now, we know this distance here. It's 300. Now it's 300 billion meters, so I don't want to write all of that. So I'll just write 300. But for me, I just need to remember that my units I'm using is billion meters. 300 times 10 raised power 9 is fine, but even that I'm too tired to write down. So I'm just going to leave it as 300 and just remember that my units are in billions of meters. Okay, so some things are easy to find here. So, I mean, we can get this angle easily. The total has to be 180. So that's 30. 30. Right, I will actually say 150 and 150. I'll split it in two, and I'll draw a line. Okay, maybe it's a mistake in mine at the back. I'll fix it if it is. I'll do it right this time. Okay. So, do I have enough information here to work out this distance? Let me see. I have a distance. I have an angle. No, actually, I don't think so. I think I was right the first time. I think I will have to go back to saying this is 300 and this here is 30. What would I work out? I need to get some sides, that's for sure.
You have one side.
I have this one. I can get these two.
Yeah.
I guess it doesn't really matter. Let me just get this one here. I'll call it x. So I can say x over sine 80 equals 300 over sine 30. That's me using the sine rule. X over sine 80 equals 300 over sine 30. Right, so then I get x equals 300 sine 80 over sine 30. Okay, 300 sine 80 over sine 30. Is that right? Yeah. 590.88. Okay, so I know this side now. I think that's enough, I think. Is it? If I draw a line here now, do I have enough information to get this side? I have a side, I have a side, I have an angle. Yeah, so I can use cosine rule. This is 150 here. So if I call this d, I can say d squared equals 590.88 squared plus 150 squared minus twice 590.88 times 150 times cos 70, using the cosine rule. So if I just hit that in on the calculator, 590 squared plus 150 squared minus twice 150 times 590 times cos of 70. That's my d squared. So if I square root it, 557.68. 557.68 times 10 to the 9 meters, which is 557. I want to change that. 0.68 times 10. 6. No, what am I? Sorry. 10. Yeah, 10 6 times 10 3. What's wrong?
Why are you doing that?
I want to just change it to kilometers because it's a bit more. Well, how do I give the answer? I give it as meters, kilometers.
Meters.
Oh no, I left it as meters. Okay, that's fine. Yeah, so 557.68 billion meters. Now, actually, I should round it off. So yeah, 3 significant figures. So that's 558 billion meters then. Okay. Right. Okay. Yeah. So most of you didn't get that, right? Yeah.
I was doing the same thing, but for some reason I got the same.
Ah. That's why I'm the teacher and you're the student, perhaps. I've got a slightly better chance of getting it. Yeah, that one was a tricky one, which is why I put it in there. I like this one because it makes you use both the sine rule and the cosine rule. And I often find in the exam they sometimes give you questions where in part A you have to use one rule and in part B you have to use the other rule. I never see them give you questions where you have to use the same rule twice. You know, I never come across a question in the exam where you have to use the sine rule twice or the cosine rule twice. It just doesn't really happen. But it's certainly possible that you need to use each rule once. Okay? So since all of you had trouble with this, please write it down carefully. I think you agree it's quite amazing when you actually see it done. It doesn't look so difficult now, right? Okay, when you're ready, we'll go on to 3 next. I hope 3 wasn't too bad because we did do 2 examples of it in class. So let's have a look here. Mosa, have you got it or do you need a minute? Are you sure? Okay. 3. A student of maths is standing near a building. She looks up and notices that her line of sight makes an angle of 45 with the ground. She walks 5 meters and notices it now makes 50. How high is the building? Right, so there's the building. It has a height. She looks up at an angle of 45 degrees. She walks 5 meters and looks up and makes another angle of 50 degrees. And this distance here is 5, and we're using units of meters. Okay. Now, we did this one in class. We did one very much like it. Yeah, very, very similar. I think, just change the numbers a bit. I do wonder if I should show you how to do it a different way, or should I just do it the same way? Okay, fine. If you're wondering, there is another way to do it. Anyways, okay, so let's work out all the missing angles. So if that's 50, then that one there has to be 130, because the total here is 180. If that's 130 and that's 45, that's 175. So that means this guy here has to be 5. If that's 50 and that's 90, that's 140. Which means this one here has to be 40. Right. The trick here is to get this side first, which I'll call it x. And I think we can do that easily with the sine rule. We can say x over sine 45 equals 5 over sine 5. 5 and 5, coincidentally. So that means x is equal to 5 sine 45 over sine 5, which equals whoops 40.57 meters. Now, if we look at this triangle, it's a regular right angle triangle, so we can just use our SOHCAHTOA. So we can say that sine 50 degrees is equal to h over x. So that means h is equal to x sine 50, where we worked out the x just one moment ago. So using our 40.57 and multiplying it by sine 50. Great, let's have a look here. 31.1. Okay. This is by far the most common exam question in this topic, and they've given something very similar to this several times in the exam. Okay, so this is definitely, of the 3 questions, the most important one so far. In fact, the next one we're going to do, number 4, is again very similar to number 3. So once you write this down, we'll have a look at number 4. I can't quite remember off the top of my hand, but it's actually using tan. It's something like, you say tan 45 equals h over this distance, and tan 50 equals h over this this smaller distance here. Yeah, it's something like, here, let me just do it on the side here, because I actually don't think it's too bad. If you call this distance here d, as an example, you could have said, as another way to do this, tan 45 equals h over 5 plus d, if you look at the big triangle. Then if you look at the small, tan 50 is h over d. Now what you can do is you can get d equals h over tan 50. And you can sub that in here for d. And now you have one equation for h to solve. But I don't, now that I've thought about it, it doesn't quite seem like it should be any better or quicker than what I just did there. Yeah, it's not as bad as this method, because you're not dealing with having your variable in the denominator. A beer? Question? No, you sure? Go ahead. It's just a calculator thing. Yeah, okay. You're not in radian mode, are you? No, okay. Because 90% of the time when students don't get the right answer, it's because they left their calculator in radian mode. Yeah. It's okay? Yeah? Shall we go on to the next one? Yeah. Okay. 4. Lou is standing on top of a vertical cliff pointing north. He looks down at an angle of 40. He's looking at the southern tip of an island. When he looks at the northern tip, he makes an angle of 30. So what happens here is you have an island, and he looks down at the southern tip, and that angle is 40 degrees. Then he looks at the northern tip, and that angle is 30 degrees. And the island is 1 kilometer long. He knows this because perhaps he was there sometime before. So he's actually able to work out how high the cliff is that he's standing on. It's very similar to the last question. What is this angle here? Who can see what that is? Now remember, this total angle here is 40 and the smaller angle is 30. So what's this angle? 10, good, 10. Now this is 90. Now if this is 40, what's this angle here? 50. Now if that's 50 and 90, then this one here is 40. If that's 40, what's this one? 140, I was going to say 130. Right, if that's 140 and that's 10, that's 150. So then this one here is 30. So just like the last one, we have all the angles. And just like the last one, the trick is to get this side here first. So we can say x over sine 30 equals 1 over sine 10. So that means x equals sine 30 over sine 10. Now when I look at this triangle, I can say, I'll call this h. I can say sine 40 equals h over x. So that means h equals x sine 40. So once you get the x, you just multiply your answer by sine 40 and you're done. So we have sine 30 over sine 40. No, what the heck was this number here? That was a 10. 10. And then multiply by sine 40. Right, so 1.85 kilometers. Here it is, here. X over sine 30 equals 10 over sine x over sine 30 equals 1 over sine 10. Yeah. Yeah, believe it or not, that's a H. Okay, shall we do number 5? I think my answer for number 5 at the back is wrong, so I'll do it now and we'll see what we get.
We did number 5.
Yeah, but I'm going to do it here so that you have all the answers in one video then. So if you're doing revision later, you can easily find the answer for this one. So this one is 5. Okay, so we've got our Earth, we've got our mountain. He's looking off the horizon, which makes a tangent with the circle. There's the radius of the Earth. There's another radius of the Earth. We're trying to work out the radius, aren't we?
Yes.
So that's R and that's R. Now he knows how tall the mountain is. It's 321 meters. And he also knows the angle he looks down at. So if I draw a line here, he knows this angle. What is it? 0.567 degrees. Now that angle is a little bit messy to write, so I'm just going to call that angle alpha. Okay. So this angle here will be 90 minus alpha. Agreed? Yeah. This is 90, so this angle here will be 90 minus this red angle. So it's 90 minus alpha. So if you were to put in the numbers, it's a little messy for me to put in the numbers, you'll actually find that this angle is the same as alpha. And if you don't believe me, calculate it on your calculator. This will be something like 89.5. If that's 89.5 and that's 90, then this will be about half a degree. Yeah. So you can trust me on it. It is alpha. Now we can say cos alpha equals r over r plus 321. Cos is r over the hypotenuse here. So we can say r plus 321 cos alpha equals r. So that's r cos alpha plus 321 cos alpha equals r. So that's 321 cos alpha equals r minus r cos alpha. I will take the r out. So that's r 1 minus cos alpha. 321 cos alpha. So I can get r equals 321 cos alpha over 1 minus cos alpha. So let's hit this in on the calculator. 321 cos, what did I say alpha was? 0.567, wasn't it? Over 1 minus cos 0.567. Yeah, so it's, if I put it in kilometers, it's 6600 kilometers. I think I asked for two significant figures. 6600 kilometers, where at the back I wrote 63. Both fine, because the only thing I ask you to do is give it to me two significant figures. No, they don't come up in semester 2. I don't think so. I think they were removed, so we don't do vectors. Okay, continue. Yeah. Now, number 6. Ship A is 40 kilometers east of ship B and also 30 kilometers north of ship B. So if there's ship B, ship A is out here, it is 40 east and 30 north. Ship A is not moving. Ship B heads northeast. So it's heading at 45 degrees. That's what northeast means. How far has ship... Northeast is exactly halfway, 45 degrees, yeah. How far has ship B travelled when ship A and ship B are nearest to each other? Right, so what's interesting here is when ship B is travelling along here, here's ship B, and at some point here, ship B will be nearest to ship A. And what's interesting about this point is that this is 90 degrees. Okay. Now, let's have a look here. Yeah.
How come the line is because it's northeast when west is east?
Say again?
How come because this line, the line with the red dot?
This one? Oh, this one?
Yeah, how come because it's northeast?
That is northeast, isn't it?
Yeah, that's not northeast. Northeast. West is okay.
North. No, hang on. North, south, east, west. Yeah. This is northeast. Yeah.
So like a line opposite west will be northwest.
Wow. I don't know what you're saying.
I think she thought that, because it's on the side, basically on the west, she thought it.
I have no idea what's going on, but what I will say is if I say to you travel north, it means this way. Travel south means this. Travel east means this. Travel west means this. Travel northeast means this. Travel northwest is this. Southwest is this. And southeast is this.
Then how come northeast is this way?
Oh, I have my little arrow here. This is.
Oh, okay, yeah.
Are we cool?
Yes.
Okay. Right. Okay. Back to this. So what I'll do is I'll draw a line from here to here to make a triangle. Now, if you look at this triangle, this side is 40, this side is 30, this side is 90. So you could work out the hypotenuse, couldn't you? From using what? Pythagoras. So you can get that this side will be 50 from Pythagoras. Are you early or late? He is early. Yeah. Come back in 10 minutes. Yeah? Did you have individual tutorial? Go get a cappuccino and a pastry or something. Yeah. Do you think he understood that I meant for him to get me one? Or was he thinking I should... Okay. Right.
Do you, why, sorry to ask you this, but why is it, how is it 90 degrees from the
Oh, this 90?
Yeah, why?
Yeah, because it's like a little fact nearly. When something, if you have a point and a line, the place where this is closest to the line is a 90. Yeah. Okay. Now, back to this triangle. I want to zoom in just to make it a little bit clear. So this triangle here, this is 40 and this is 30, and Pythagoras says this is 50. Now we can get this angle here. We could just do a tan inverse 30 over 40 gives us the angle. So let's work that out. $36.87. Okay. Oh yeah. Typed in that. Yeah. Now, that's useful because if I know this angle, 36.87, and I know the whole thing is 45, then can I know the smaller angle? Yeah, it's just going to be 45 minus 36.87. And that's 8.13 degrees. Now why is that useful? Well, if I look at this triangle, yeah, I can work out this side now because I can use sine. I can say sine 8.13 is equal to opposite, which I'll call d, over hypotenuse, which is 50. The longest side is 50 in this triangle here. So I get d is 50 sine 8.13. $7.07 is the answer. kilometers. That's only part A now. Oh wait, oh, I misread, sorry, I'm not quite finished. I've only worked out D, but actually my question was what is the distance it travels, so I'll call that L. So look, if I know 50 and I know D, then I can use Pythagoras to get L. So let's do that. So I can say L squared plus 7.07 squared equals 50 squared. So L equals uh, 49.50. Let's see. There we go. That's better.
So that means because 50 also gives the 90 degree.
Yeah. Okay. Is that okay, guys? Can I continue? Part B? We know that ship B can contact ship A if they're 40 kilometers apart. So ship B will be 40 kilometers apart, and then it will be not 40 kilometers apart. How long does it travel while it's 40 kilometers apart? So what's happening? No, it's continuing with this one.
Yeah, but we keep the D same, yeah?
Oh yeah, but everything's the same here from this picture, yeah. So what's happening is, here's B, is it?
No, A is not.
A is not moving. So there's A. So B is moving along here. We've worked this out. We worked out this distance. We said it was, what was it? 7.07. And we worked out this distance here. What did we say it was? 49.5. Okay. Now, look. At the very beginning, how far away is B and A at the very beginning? If you look at your last picture, you can figure it out. 50. And what happens as time passes? Does it come closer or further? Closer. So at some point, let's say here, they will be 40 apart. I'll put that in a different colour, sorry. They'll be 40 apart. Okay? Now, this actually is not so bad, because if you look at this triangle, it's right angle, right? You have the hypotenuse, and you have this side. It's 7.07. So you can know this side if you like. That's what we want, well, nearly. From Pythagoras, we get square root 40 squared minus 7.07 squared. So 39.4? Okay. But that's not quite the answer, because remember, the ship continues. It's still 40 all the way until here, when it leaves the range of 40. So your answer is actually 2 of these. So it's 2 of them. 78.74 is the answer then for this distance. Only one part left, and then we'll finish it there, and I'll continue with the other questions in the next tutorial, which you can watch in their video. Got that? Continue. So, next part. The ships can only be 2.73 kilometers apart at their closest distance. What angle can ship B sail at? So we're still back in this picture. What did I say this was? 40 or 30? I forget. The bottom. 40. And this is 30. So we want to know what angle must ship B sail at. So the distance here at its smallest point is 2.73. Okay, well look, we know this distance here is what? What's this distance I just drew? This one here. What's that? That's 50. Okay? And we know that this is a right angle. And we know that this is 2.73. And we really want this angle. And we know this angle anyways. What is it? It's, what was it, like 36 or something? 36.8. Okay. So look, we can just simply say sine alpha is 2.73 over 50. So alpha is sine inverse of that. So that is 3.13 degrees. Now let me add that to our 36.87, and that's 40. Is that right? Yeah. That's 40. So in other words, the ship B can sail at 40 degrees. Now, what would happen if it sailed at less than 40? Well, if the angle was less than 40, then the distance between A and B would become less than 2.73 up here. Could it sail at more than 40?
Yes.
Yeah, it could, couldn't it? I mean, more than 40 would be good because it'd be further away. Okay? So it can sail at any angle greater than 40 degrees. It could even equal 40 degrees. They don't seem too bad, or they're not great, I know.
So other than these types, nothing else is fine.
For what now?
For the example.
To be honest, I'd say question 3, 4, and 5 are most likely exam questions.
7 maybe?
Maybe 7, yeah, maybe.
I like those numbers.
But, yeah. 7 maybe. 6 has come up once.
Okay.
That's the one we just did.
Okay.
It was okay. It came up the year I wrote the exam for Manchester. So, that's why I have number 6 in here. But whoever writes the exams at the moment, they seem to like questions like 3, 4, and 5. Their choice. Okay, so what I'm going to do, with the next group of students, I'll continue with question 7 onwards. So I'll just call this video tutorial sine and cosine part 1. And the next one will be part 2 then.